Hello everyone, I'm Matthias. I'm a Senior Product Manager at Push Technology, and thank you for joining us today for another episode of our webinar series. I would like to start by sharing a little bit about myself. I joined the company about 3 years ago to focus on user experience and how to bring all the power of Diffusion, which is our leading product, to the hands of developers out there. Before that, I spent most of my career at Apple building AI products, including Siri. And before that, I worked for Google in one of Google Maps' main data collection efforts. For the past year, the priority for me has been to help the developers community to build applications that require data distribution over the internet, real-time experience, and fundamentally super simple development libraries through an intuitive and powerful SDK. Today, we will try to do that by introducing a sample application for flight tracking using live data feeds and looking under the covers of Diffusion Cloud platform. We will briefly go over event-driven architecture, and of course, we will share the code that makes it possible. Let's get to it. In a moment, we will go into our Diffusion Playground and try this flight tracking sample application. If you prefer, you can open this URL in another tab so you can play with it later. The web page is pushtechnology.com/diffusion-playground. As we mentioned, we will learn how to navigate through Diffusion Playground, play with some live data feeds, and introduce the basic concepts of data wrangling, and of course, get the source code from GitHub so you can try it later. Let's see it. Okay, so this is what the playground looks like. We'll do a demo in just a moment, but before that, let's identify the different sections here. Let's begin with the consume section. The consume section reflects the different ways we can consume data into Diffusion from any type of data source. It could be a database, could be a backend service, something using Kafka, REST, IoT sensors using MQTT, web applications, mobile applications. So basically, anything that is generating data can be consumed into Diffusion. In this case, we're going to use a flight tracking JSON stream as shown in that section. Next is the source data visualizer. In this case, the source data is coming from an open source called openskynetwork.org. It basically provides a REST API with real-time flight tracking information. All the flights, commercial and private flights globally, are being reported regularly through this REST API, and we're consuming from that. And of course, we also have a data counter, which is basically the accumulation of bytes over time that this data source is producing. So we're just counting that data there. The next section is the deliver section. This one focuses on exemplifying through this schema all the places that we can consume data or deliver data from Diffusion. IoT sensors can subscribe to data from Diffusion, again, database, backend services, or any web or mobile application. In this case, the subscriber application to which we're going to deliver data from Diffusion is going to be a flight tracking web client. And this section is trying to exemplify that. The next section is the web client application itself, which in this case is a map that shows all the flights that are flying in this area. In this case, for the example, is in the Los Angeles area. And there's also a drop-down menu to filter by different airlines. And of course, there's also the data counter of the data that is being delivered to the subscriber web application. In this case, we can see that by just adding diffusion between the data producer and the data consumer allows a very substantial data savings through the delta compression mechanism that Diffusion offers. We will talk a bit more about that later in the webinar. Last but not least, we have the diffusion section or enrich section here, where basically we're going to show all the magic behind diffusion, how diffusion can take any data stream, in this case a JSON stream, and automatically on the flight, on real time, can turn that stream into a very intelligible data structure that then consumers or subscribers can pick specific elements or portions of that stream and subscribe only to a part of it and not the whole stream, the whole JSON. So we're going to focus on that section, the Diffusion Enrich section, to learn more about the value proposition behind Diffusion. So before we get into the demo itself and the app, let's talk a little bit more about the data source. In this case, openskynetwork.org. Again, it's a JSON stream coming from a REST public API. This has, all the flights, thousands and thousands of flights, both commercial and private, that are flying right now around the world. So this is a big JSON that usually a flight tracking app would consume the whole JSON and then process and filter the information in either a backend service or in the app itself. So it would be consuming the whole JSON. What we're going to show through this webinar is how we can treat and process this information, this data, this JSON in a more efficient way so that we can bring real-time experience, virtually no latency, and fundamentally savings in data cost, basically subscribing to the specific portions of the data that a subscriber client needs to show or present for users and not the whole stream or fire hose. Let's take a look into this big blob of information, of data. And what you see from this JSON is basically very long array of flight information. So each portion will contain the information about each of the flights that are currently flying around the world. That information will include things like the call sign, which is the ID or flight number. In this case, is an American airline flight 1063. Also the country of origin, which in this case is the United States. A bunch of timestamps of last time reported, the current timestamp, latitude and longitude, of course, the location and altitude, the ground speed, orientation of the flight, and a bunch of more sensor data from that flight. And this information repeats by the thousands again for each of the flights that are currently being reported by these JSON stream. So what we're going to try to do here is put all these data into Diffusion so that we can start processing the information again on the flight and in real time based on the information or portions per flight. So let's see how Diffusion does that and what is the value added by Diffusion by doing so. So as soon as we add our SDK libraries in the data producer, what Diffusion can do is, in a very intelligent way, will detect any changes between subsequent messages and only send the delta of the message to Diffusion and, of course, to the subscribers. That will enable or allow data savings that could be up to 99% compared with not using Diffusion to publish or subscribe to that data. In this example, for instance, we can see that the first message that the data producer, in this case, the JSON stream from openskynetwork.org, it will be sent completely. But then subsequent messages, we're only sending or publishing only the delta, so the changes. So between the first message and the second message, only one digit in the timestamp and only one digit in the longitude has changed. Same thing with the third message. There is a change in the timestamp, there is a change in one digit on the longitude and the latitude and in the speed. And as you can see, furthermore, there's always a small portion of the data that changed between one message and the next. So there's really no need to send every message complete, but only the deltas. And Diffusion can basically reconstruct the message in the destination, in the subscriber, allowing data savings, again, up to 99% compared with not using Diffusion at all. The other very important capability for Diffusion customers is our data wrangling capability. I want to quickly talk about that before we get into the demo of the flight tracking application. And in this case, what we need to really highlight is that on top of the delta data savings, which is basically the compression and only sending the difference between messages, we can also automatically organized JSON message on the flight in real time in Diffusion. So as Diffusion is consuming data from any data source, and in this case a structured message like a JSON, we can automatically, through something called Diffusion topic views, we can build a topic tree. A topic tree is an intelligent data structure that resembles what the data or the nature of the data coming in looks like. So in this case, Diffusion is able to take a look at the different portions of data within each of the flights and quickly be able to break it down by airlines. So instead of having a big stream of flights, you can start grouping data by airlines. You can group them by status. Is it a flight that is in air? Is it landed? Or you can even take a look at specific flight numbers. And that is all created in real time. As the data change, these trees will change, will dynamically update or adapt to the nature and the changes of the data in the source, allowing then the subscribers to only subscribe to the topic that they need. Let's say a subscriber only cares about flights from American Airlines. They don't need to consume the whole JSON. They can only consume the topic that belongs to all the American Airlines flights. Or there is a customer, there is a user of the flight tracking app that only cares about specific flight. They're a family member arriving on a given flight, and the only information that they need to consume from the JSON is a specific flight. So they can subscribe to only that flight and not the whole JSON. Or again, check by status of the flight. Has it landed or not? So in that case, they don't need to consume the whole fire hose, but only the portion that they care. And they can do that through Diffusion topic trees. So here we can see how Diffusion can identify the portion of the JSON stream and map the parts that are, in this case, flights that had landed into specific topics and group them into topics that then the subscriber can subscribe to. The more granular, the more fine-grained the topic subscription is, the more data savings the consumer will see. And here for this example, you can see that we can also identify a specific flight and only subscribe to the changes in the values for that flight only. And in the example for the JSON stream from opensky.org, we have seen data savings that are over 99% when subscribing to one flight only. And towards the end of the demo, we will take a look at how we can access the source code of the Diffusion Playground, the flight tracking app, which is available in GitHub. So we're going to take a look at how we can access that code, and we're going to also navigate through GitHub so you can understand where all the components and all the README files and tutorials, so you can play with the app and the source code, especially the SDK after the webinar. So let's get to it. Okay, so it's demo time. Let me open my browser. Okay, so we are on Chrome browser. I have just typed pushtechnology.com, which is our website, /diffusion-playground, and that will take you to our website and to the flight tracker application sample. There is a top banner with a short video I recommend you watching. It's about what Diffusion is, what it's all about, what is the value proposition, who we are and what we do. So if you have a minute or so, please take the time to watch this video. I think it's going to give you more context of what we do. There's also a few call to actions. You can, of course, try Diffusion Cloud for free from here, or log in if you have an account already. And of course, we invite you to go through 3 steps. Steps 1 is basically playing with the flight tracking application, which we will do in a second. The step 2 is to get the code from GitHub and learn how it is implemented. And the step 3 is to sign up to Cloud and get to enhance and even do more with this flight tracking app or any other code example application. So let's get to it. So let's play a little bit with Diffusion Playground flight tracking application. So as you can see, and we mentioned before, we have the 3 sections for consume, enrich, and deliver. In this case, we already have data coming in from OpenSkyNetwork.org. with flights that are flying right now. You can see data will be updating as the REST API pulls new data. And you can see those flights here. We're kind of grouping the flights so that these, in this case, Leaflet, which is the open source maps that we're using, can deal with the many flights that are flying over this area, which is in this case is Los Angeles. Of course, as you zoom in, you get to see more flights. Let's zoom into the airport area, which I think it's here. Here we have the airport. Let's zoom in even more. So you have a couple of flights that are approaching the runway. They're about to land. Some of them either landed or are about to. And of course, we can zoom out around the area. Let's zoom a bit more. And of course, we can filter by airlines. So you can only see American Airlines or let's say Delta, Southwest, and so on and so forth. Also, you will see here a table. That table is all the information that is coming per flight, which is here. Let me grab one of the. So that information that includes the iCloud 24, which is a standard identification for flights. The more common one is the call sign. In this case, it says Southwest Airline flight 1013 from the United States. The last time we got the position was at this timestamp. The last contact with the plane was at this timestamp. The longitude and latitude, the altitude is on the ground, yes or no. The velocity, the true track, which is the orientation, what direction is the flight going, vertical rate, some sensors information, and a bit more information that we're not going to go into details right now, but it's all there in those tables. There are a few more filters that you can apply, by altitude or also by speed. So under 200 miles an hour, more than 500 miles an hour, and so on. This is basically what, it's a very basic flight tracking app, but this is basically what we kind of implemented here. The interesting thing, as let's say in this case, we're consuming all the data. It's absolutely everything that is coming from that JSON that in its source has produced 5 megabytes, in this case, a bit more than 5 megabytes. By putting diffusion in the middle, we're already saving 78% of that data. Instead of having to consume the 5 megabytes, we only consume 1 megabyte. We're still sending all the information, it's all the flights, but because we're using Delta data and only sending the changes between messages, we're already saving a lot in data. And of course, that also affects in a very positive way the latency, so we're reducing latency as well. But we're still consuming the whole JSON stream. But on top of that, when we start filtering, and now the web client application is only subscribed to American airline flights and not the whole JSON stream, we're now sending even less data. So it's only 65 kilobytes. And we're basically saving 99% of the data. If the web client, the map, would continue to consume the whole JSON, when we only want to see a very specific set of flights, we would still consume the 6 megabytes and counting versus 68 kilobytes. And that is allowed because, as we mentioned, we have this thing called topic tree, which is as the JSON is consumed by diffusion, we can make some logical structure to that JSON. So let's see how that works. So as the data is coming in, that JSON is coming in, we automatically build a tree. And that tree is basically a set of topics. We can still consume the whole source, the OpenSkyNet.org source, which will have all this is a very long JSON, which contains all the flights. Or we can say, what? I don't want all the flights. I only want the American airline flights, and within the American airline flights, I want this specific American airline flight, which is the 1955. And that has a JSON with only that flight. And this is constructed on the fly. So as each JSON is coming in real time, this virtual structure or topic tree is built based on the nature of that data. So we can see, by airlines, we can have all the flights listed. Again, each topic will contain only the flight that you care about, or by status, is it landed, true or false. So these are all the flights that are still in air versus all the flights that are landed, which basically the way it works. So it's checking one of the elements of the JSON and it's checking landed true. If so, it's grouping that into a specific topic for landed true. So let me close this very quickly. As the subscriber web application wants to show specific data, is no longer consuming the whole JSON. Is at that point only subscribed to a specific topic or set of topics within the topic tree structure. And that's basically, as we were explaining earlier, how you can go from, let me go back to consuming all the flights, how you can go from consuming a 8, almost 9 megabytes data source, if you're just consuming the whole stream from your publisher to your subscriber, to saving 78% of in data by using Delta data savings by just switching to Diffusion. And on top of that, if you're using the automatic topic views and topic trees, you can save even more by subscribing only to specific portions of that whole JSON stream. So here is, for you to play a bit more, to play with the with the topic tree, with how different topics are built. I'm going to show you a bit more before we go into the code. Here I have the console. As you create your free account, you will have access to your Diffusion console. So let me log in to the service or the cloud service that I have hooked for this flight tracking application. So let me go to topics. So in this case, I'm going to make this one a little bit bigger for now. We can see here, let me open this one back. The topic that we are basically consuming is within REST, because we're using a REST API. So it's here, the one right here. So we have REST, we have the OpenSkyNetwork.org, which contains, again, the full JSON as it is produced in the source. But then we have all these different views that we already saw here in the app. But how these views or topics are automatically created. So the way it works, we're not going to go into too many details, as is something for another webinar series, which is topic views. So how do we build the different views so that it automatically turn your JSON into a rich topic structure, a topic tree? So let's see one of them. For instance, American airline. So how you build, you put a name to your topic views. How do we build an automatic tree that updates itself as the data is changing in the source topic? We just use some regular expressions to say, we're going to map a topic. In this case, we're going to map everything that is coming in the main source topic, and which the flight number starts with AAL. Let me go back here. So as you can see, let's grab. So you will see for every call sign, the first 3 letters describe what airline it is. In this case, is SkyWest for AAL. Let's see if we find one here quickly. So no, it's not that obvious, but you will see it starts with a 3-letter and a bunch of numbers. So we can look at that JSON and say group in a topic within the same path called Airlines/American, all the flights that starts with AAL. So there's more documentation on how you can write regular expressions to build your topics, but you can see how simple and legible it is to basically build any topic view. Let's go back to the topic browser. And again, you can see here, and then from that point on, your subscribers can only subscribe to the portion of the data they want, and not the whole JSON. So that's kind of the point here. So as you create your own Diffusion Cloud account, you will get access to your Diffusion console, and you can play with the topic trees. You can create more topic views, and you can think about more use cases that you can build around. And of course, the last thing that I think is important to mention is if you want to learn more about the code, you click here, you share your email, and we're going to send you an email with access to GitHub. Okay, so here we are in GitHub, github.com/diffusion-playground. So here is the code for the flight tracking application. There's a brief introduction to it, and of course you can navigate through all the different components and files, but we recommend learning more about first how to install this locally. So we'll give you all the steps to build the special directories, everything that you need to know about deploying these in your server. But we recommend you start with all there is to know about the Diffusion SDK, which is what we're going to be using for building this flight tracking app, both for publishing data from the data producer into Diffusion, as well as subscribing to that data from the web client, in this case, the flight tracking app. So let's click here and read a bit more. So here you will see what are the files, the JavaScript files. Again, as mentioned earlier, this is a code example in JavaScript using the JavaScript Diffusion SDK, but we have support for Android, Java, C, .NET, Objective-C for Apple, Python, and more. So feel free to explore a bit more about the different SDKs in pushtechnology.com, but in this case is focused on JavaScript code example. So for all the different files, the Diffusion client, the service, the flight tracker tree, which is the one that you saw at the very end in the middle, all the components are here. Now, how you basically connect to Diffusion, how you publish data to Diffusion, how you subscribe to that data as well. You will see that for every API call to our SDK is pretty simple and straightforward. You basically need to call the connect function, pass on the host name and the credentials, the username and password. Things for instance, to create a topic, once you have a session created, you can easily add a topic with a topic name and a topic type. In this case, the REST API is producing a JSON, so that's what we're consuming. So you can see here, basically how we have built this, and it's all pretty simple, straightforward, self-contained. So you can go ahead and play a bit more. All the different components of this flight tracking app, and of course, take the time to add more features and more use cases as you create your own Diffusion Cloud instance and start playing more with the different topic views and topic trees. So I hope you really get the time and the chance to play a bit more with this. And please feel free to shoot us a message on Intercom on the Diffusion Playground page if you have any question or you need any help using our SDK. Okay, so I hope you guys have enjoyed the demo, and of course we want to allow a few minutes for any question that you might have. So do not forget to use the Q&A button to ask questions. I will try to answer a couple of them here. So the first question that I see here is Diffusion Cloud free, or is there any cost to it. So Diffusion Cloud and on-prem, which is the version that you can download and install on-premise, both are free. There is a certain amount of bytes and messages and a quota that you have for the free tier, but you get to enjoy the free version and all the capabilities for 90 days. And during that time, you can reach out to us, ask questions. We can help you and guide you through the process of onboarding and starting using the SDK and start using your Diffusion Cloud service. And it's all free. We want people to get on board with Diffusion, see the value, see how much it can improve the performance and the power of their applications while using a very simple SDK, so they can quickly get out to market. But yeah, the answer is free, and it's available on our website at pushtechnology.com. And the other question here, it's about the Diffusion Playground flight tracking application source code that is open, that's available for everyone to download. The idea is a code example based learning. The idea is that you can learn more about the different capabilities and how easy it is to use our SDK and our library by doing so through an example, a code example that you can download, that you can play with, that you can improve, that you can add more features. In this case, the code example is using Vue, JavaScript, but we support more programming languages, including Apple, Objective-C, Java, Android. We have .NET, Python. We even support HTTP protocols like curl commands. So there is a big flavor of SDK support for your preferred programming language. But in this case, and this open source for Diffusion Playground flight tracking app is built using the JavaScript SDK. And of course, don't forget to go to pushtechnology.com/diffusion-playground to start playing with our flight tracking app. Thank you so much for your time, and hope to see you all in our next webinar series. Have a great day.